Hello, we're up here on a Herring Creek. I'm going to do a few videos on the normal distribution, and our data setter is going to be rainbow trout. Rainbow trout live 4 to 6 years and grow about 20 to 30 inches and weigh 8 pounds when they're mature. Our largest rainbow trout ever caught was 57 pounds, and they figured it must have been about 11 years old. Rainbow trout are members of the salmon family, and some of them migrate to the ocean for several years, where they're called steelhead after that point, and they have to return to their stream of birth to spawn. So basically we're going to use 25 inches for the average length of these trout and a standard deviation of 2.7 inches. The two values I somewhat estimated from the 20 to 30 inches I gave you. So let's look at the normal distribution. The normal distribution, which is bell-shaped, is one of the favorites of statisticians because a lot of things in nature are normally distributed. Tree heights, lengths of trout, weights of trout, and body parts of humans and other things. So we're going to look at the normal distribution in several ways today in a series of a few small videos. We'll see if it works out well. This is my first attempt, so if it doesn't come off good, please give me a break. Let's look at the normal distribution, and basically the empirical rule, which is one of the estimations we use when we don't have tables and we're out in the woods. But by the empirical rule, 68% of data is within one standard deviation of the mean, 95% is within 2 standard deviations of the mean, and 99.7 roughly is within 3 standard deviations of the mean. And these standard deviations are standardized deviations, where we standardize any distribution into a standard normal distribution that has a mean of 0 and a standard deviation of 1. So these are standardized using the formula z equals x minus mu over sigma. Now, z is the z-scores we're going to use and use for the 68, 95, 99.7 today, but in normal use we have tables that we look at. So x is our data values. In this case, x is going to be the lengths of mature rainbow trout. Mu is the population mean, which we're assuming again is 25 inches. Sigma, the population standard deviation, we're going to use 2.7 inches for our video today. So let's do a couple simple problems today. I'm going to try to limit the use of the whiteboard, and if you don't quite catch what I was saying, just rewind the video and listen to it. You might write it down, and when I put these problems up and I'll pose them, pause the video and try it on your own maybe. This is basically made for review for my UC Merced students, so I'm sure I'll eventually delete these and edit them and improve on it basically. So first of all, let's look at C. We want to find a 95%. We want to know what values 95% of all mature rainbow trout weigh between. So basically, again, for mu, we're going to use 25 inches. For the standard deviation, we're going to use 2.7 inches. And then we want to know the probability that x is between, we want to know 95%. What values 95% of the trout are between. So let's basically draw the bell curve. And then in the center of the bell curve, we're going to have that 25 inches. And we have two axes going on here. We have the x-axis, which is the actual values of our data, And then we have the z-axis, which we're going to convert our x scale into a z scale, and then use that 95% value that we're going to find which values of the trout lie between. So we know that since we're looking for this 95% values, we're going to use a -2 and 2 for our z-scores. Okay, now what we're going to do is use the formula z equals x minus mu over sigma. And we don't know these x values. Let's call this x1, which we don't know. And then we have x2, which we don't know. So we're trying to find x. So then we look at, what do we have here? We have mu, we have sigma. We're trying to find x. So we know we're trying to find x, and if we didn't already have that -2, we would have narrowed it down to, let's find the z-scores, then we can solve for x. So if we multiply both sides by sigma, then we get x equals mu plus sigma z after we add the mu to both sides. So then to do our computations, basically we're just going to plug in x for x1. We have mu is the 25, our standard deviation is the 2.7, and then we have -2 for our z-score, so we get x1 equals, excuse me, eraser, we have 19.6 inches. We do the same thing for x2, and let's just kind of get through this. I'm on the side of a mountain and it's steep and it's getting me a little nervous here. So we're going to move on after this. So I'm going to just change that -2 to 2 standard deviations, and then we get a value of 30.4. So now we know these values are the 30.4 on the right side, and then on the left side we have the 19.6. Okay, to me the biggest issue is answering these things and making sense of the results. So let's just get rid of this and write it out, and basically we would say something like 95% of all mature rainbow trout rainbow trout are between the 19.6 and 30.4 inches. And basically I'm gonna start putting my stuff away. I'll give you a few minutes alone with the waterfall down here, which is beautiful, but as I said, I'm on the side of a steep cliff and I really don't like heights, so we're gonna get out of here and move along where it's a little flatter. Okay, let's get out of here. I'll see you at the next spot.